This video is all about iteration. This is a technique to solve an equation that you will have come across at GCSE, so I'm not going to spend a huge amount of time introducing this. The basic process is, if you've got a function f of x that's equal to 0, you are going to rearrange that into the form of x equals another function, x equals g of x. You are then going to use an iterative method. So that means you substitute a number in to the g of x function, and that gives you some feedback to tell you the next number to try to substitute in. So it's a trial and improvement method, but it's a better trial and improvement method because it gives you some feedback as to the next number to try. Remember, trial and improvement, all you ever really see is if the number's too big or too small. This method gives you some feedback into, well, how far away are you? Gives you a better number to try the next time you substitute a number there. So for example, if you've got the function f of x is equal to x squared minus x minus 1 equals 0, you could rearrange that to be x equals the square root of x minus 1. Then you can use the iterative method where we say x n plus 1 equals the square root of x n plus 1. And then we start substituting some numbers in. So we start off, and you might have seen something, you will have seen something like this when you introduce the topic in GCSE. It's called a staircase diagram. This is why this method works. Basically what you do, you can see on the graph here, you've got the y equals the square root of x plus 1 function, like that. We've got the y equals x function there. And what we're looking for is where are they equal to each other. So this is the roots that we're actually looking for. Where they are equal to each other, that will be the solution to this equation. So what you do is you pick a starting value, x0, you substitute it into the g of x function, which in our case is this one here, so you substitute it in, and that gives you a number back to try. So you then get your x1, and that's the next number that we're going to substitute in. So we substitute x1 in now, the answer you get back, that gives you x2, and so on. And the more iterations you do, the closer and closer you get to them actually being equal to one another. So, that's all I'm going to say about that, because you would have introduced that properly when you did your GCSE. Let's get straight into an example. So we can see f of x equals x squared minus 4x plus 1, and we need to show that that can be written as x equals 4 minus 1 over x. So x squared minus 4x plus 1 equals 0. Right, first thing I'm going to do, because I can see that I'm going to want to divide by x at some point, I'm going to keep my x squared on the left-hand side. So I'm going to keep x squared here, and then I'm going to move the 4x and the 1 to the right-hand side. So I'll get 4x minus 1 on the right-hand side. Then I'm going to divide both sides by x. I'm allowed to do that because I know that x cannot equal 0 from that. So I'm going to divide both sides by x. X squared divided by x is x. 4x divided by x is 4. And 1 divided by x is 1 over x. And there we go. That's part A of the question done. Part B. We are told that f of x has got a root alpha in the interval 3 to 4. And I need to use the iterative formula xn plus 1 equals 4 minus 1 over xn. And it gives me my starting value of x0 equals 3. And I need to find x1, x2, and x3. So, to find x1, I'm going to do 4 minus 1 over x0, which is 3. And that's going to give, well, 4 take away 1/3 is going to be 3 2/3. Okay, that's my x1. To get x2, I'm going to do 4 minus 1 over x1. So take my previous answer and substitute it in here. calculator now, I think. And now we will get 3.72.
Yes, 7. Please report to the front office.
Okay. So we've taken x0, we substitute it in to get x1. We then take x1, we substitute it in to get x2. And we are now going to substitute x2 in to get x3. And we will get 3.73170. And there we go. So we have used x0, substituted in to get x1, then substitute that in to get x2, then substitute that in to get x3, and you'll notice that these answers get progressively closer and closer to what would be our more accurate answer. Each one of these gets progressively closer to our accurate answer. They get closer and closer and closer to our actual answer, where x equals 4 minus 1 over x, and at that point where this equals this, that's a solution to this equation here. Now, a couple of things to be a little bit careful with. This method works because our starting value and our rearrangement allowed these numbers here to converge, as in they get closer and closer to a set number. So the method worked because it converges to an answer. It gets closer and closer and closer to our actual answer. However, there might be some cases where if we chose a slightly different starting number or a slightly different rearrangement, these numbers might not get closer and closer to an answer. They might diverge. They might get further and further away from the answer that we actually want. So you do need to be a little bit careful and just be aware that this method might not work if the number that you start with, or if the rearrangements that we choose, if either of those are not appropriate, you might end up having some difficulty. It's not because you've made a mistake with the calculations, it's just because of the choice of the rearrangement and the starting value.